Important point. If Q is positive, lambda is positive, A is acting outward, direction of the electric field. If Q is negative, lambda is negative, then electric field is acting inward. And from the above equation, E is directly proportional to lambda 2 pi epsilon naught r. E is directly proportional to 1 by r. With increase in the distance, electric field will be goes on decreasing, and this is the graph between E and r. Let me discuss the second application. Electric field due to uniformly charged infinite plane sheet which carrying a charge. So when we are talking about the charge, then we are talking about the plane sheet, and then we are having a surface charge density sigma. So sigma is equal to Q divided by A, which we have already discussed in the second lecture of Coulomb's law. So let I take a sheet. This is infinite. It's carrying a charges. This is the electric field. This is the electric field acting on both the sides. So when we have a sheet, so it's a sheet. This is a sheet, and we are calculating at this point, and we are calculating at this point. So the two distance is taken, R and R. So this is the area which we are talking, and this is the area A. Distance I have taken the same. So we have the two surfaces, two ends. So electric flux is from one is from this end, one is from this end. So E vector dot ds, E vector dot ds. And the electric field is in this direction, area is also in this direction, electric field in this direction, area is in this direction. So angle is 0 degree. So we will be having this equation, and this is ds. ds is the area of this portion which we are considering about and which we are talking about the sheet. So this is, we have taken A. This is equation number 1. This is from the definition of flux. Then definition from the Gauss theorem, phi is equal to Q by epsilon naught. Q is equal to sigma A. Q is equal to sigma A. So sigma A. Then we have equation number 2. Comparing equation 1 and equation 2, we will be having this equation. E is equal to sigma divided by 2 epsilon naught. Right. This equation is the depend on the sigma. This equation depend upon the nature of medium, so it will be changing according to that. Therefore we will be having some important points. This equation does not having any term related with R. So electric field at this point, electric field at this point, electric field on this point, electric field on this side will remain the same because it does not depend upon the distance. So E is independent of distance. E is independent of distance. The graph is a straight line. If Q is positive, sigma is greater than 0, electric field is directed outward. If Q is negative, sigma is negative less than 0, electric field is directed inward. But if, the fourth case is very important, but if the sheet is thick, then the above equation changes to E equal to sigma divided by epsilon naught. Please take care about this equation if the sheet is thick. How we obtain this equation? Step up to equation number 1 will remain the same. In this case, Q is equal to sigma into 2A. Because when we are considering about the thick portion, we cannot ignore the area of both the sides. We have to take the area of both the sides. Therefore 2A should be included here. So 2 यहाँ रखेंगे, यहाँ पे भी 2 है, 2 get cancel, you will be having sigma divided by epsilon. So therefore electric, if the sheet is thick, so you have to remember whether the question is related with the thick or thin. If it is thick, then E is equal to sigma divided by epsilon naught. If it is thin, then E is equal to sigma divided by 2 epsilon naught.